Go ahead with the recording.
It's recording. Yep.
Thank you. So welcome everyone. My name is Meta Brunzema and I'd like to welcome you to the Pratt Housing Consortium Decarbonization Symposium. Fatou Jabi and I will be your co-moderators today. On Earth Day 2022, our Decarbonization Symposium will offer a deep dive into the challenges and opportunities decarbonizing the built environment, with a special focus on efforts to reduce embodied and operational carbon emissions in New York City. Our symposium will consist of welcome remarks, 5 panelist presentations, followed by a moderated panel discussion and a Q&A open to the audience. We will have a 5-minute break after the 3rd presentation. I'd like to extend a special thank you to Pratt Institute and the School of Architecture for supporting the symposium, and to the Decarbonization Working Group, especially Francis Huppert, for their efforts in organizing this event with me. We are so grateful to SOA's event coordinator, Courtney Knapp, for her tireless support. Please take note of the protocol for earning AICP or AIA continuing education credits on this next slide.
Thanks so much, Meta. Hi, everyone. My name is Courtney Knapp. I'm an associate professor in the Graduate Center for Planning and the Environment in the School of Architecture at Pratt. I'm also the events coordinator for the School of Architecture this semester, and just really excited to be able to, say that we can offer both AIA and AICP continuing education credits for this event. We can, if you are a certified planner, AICP certified planner, you are eligible for 2.5 credits. And if you are, I guess, a licensed architect and are looking for either land use or health and I guess it's welfare credits, we can offer 2 of those. So there are basically 2 links for each group that I'll be sending out in the chat over the course of this event. The first is just a sign-up sheet. So if you are either seeking AICP or AIA credits, I need to essentially get your name and your AIA number or your APA number. That's one thing that I need to turn over to those organizations. Towards the end of the event, I'll also be sending out evaluation forms for both of those organizations, and they're very short. They should only take a minute or 2, but it would be most helpful if you would be willing to do that at the end as well. So it's a way that they also can kind of track who is participating. So that would be great. And if you have any questions, you can send me a message in the chat or email me. I will add my email to the chat, but otherwise just look for the links. I'll be sharing them throughout this event. And thanks again and welcome.
To start the symposium, Pratt Institute's president, Francis Brone, will offer a welcome and share a few remarks. Let me introduce President Brone. Francis Brone is the president of Pratt Institute in New York City, an educator and leader at the forefront of interdisciplinary learning. Brone previously served as senior vice president and provost at Illinois Institute of Technology, acting provost and dean at the School of Architecture and Allied Arts at the University of Oregon, and architecture professor, associate dean, and acting dean at Rensselaer Polytechnic Institute. Francis Brone, please start your remarks. Thank you.
Sure. Can you hear me? Can you all hear me?
Yes, we can. I can.
Okay. Well, thank you. Welcome, everyone, once again. How honored we are here to have this incredibly distinguished panel and guests. As a president, as an architect and engineer, as someone who taught materials and structures, who taught embodied energy, as a parent and as a citizen, I want to thank you for your amazing work. On Earth Day and every day, I am very proud of Pratt's community's development commitment to sustainability. In so many ways, you're actively working to integrate sustainability into our academic programs and to lower the Institute's carbon footprint, if not our pedagogical carbon footprint. Well, let me give you a few examples. Since 2007, which I can't believe is actually 15 years, Pratt Sustainability Center has been the hub for Pratt's commitment to educate environmentally responsible citizens. In 2016, the center developed a program for departmental sustainability coordinators that provides faculty stipends to support new initiatives within existing programs. Currently, 13 departments participate, and in just 3 years, there's been a 55% increase in courses related to sustainability. Pratt's Facilities Management Office has also been working to decarbonize our campus, pursuing a host of strategies to meet New York City's aggressive carbon reduction mandates. Some of us would say perhaps not aggressive enough. And because of these, I would say, initial good efforts, Pratt has been awarded silver stars, and you're going to push us for much higher ratings by the Association for the Advancement of Sustainability in Higher Education. It's actually the highest rating of any independent art and design school in the United States. So these efforts are right in line with Pratt's strategic plan and institutional learning goals, and with the values and intentions of our students whose futures depend on them. Since 2005, Pratt Sustainability Coalition, which is a cross-disciplinary group of students, faculty, staff, it's worked to support Pratt's sustainability efforts, including what we're in right now, of course, the Spring Pratt Earth Action Week with over 20 events, the student-led initiative with AVI Fresh to ban single-use plastic water bottles, and the Give Take Art Supply Recycling Initiative coordinated with Pratt's Facilities Office to ensure that supplies that would otherwise be just thrown out and discarded get to students who need them. 55,000 pounds of materials have been recovered and redistributed since the program's launch in the fall of 2016. We know there's so much being done and so much for us to do. I have to say, we look forward to the expansive thinking and proposals this event will bring. I want to thank you all for your commitment to decarbonization. Have an amazing symposium. We look forward to it. Take care. Back to you, Meta.
Thank you, Francis. I'd like to now introduce David Burney, the chair of the Pratt School of Architecture Housing Consortium. David, take it away.
Hey. Thank you, Meta, and happy Earth Day, everybody. There's a bit of a racket in the background. It's my dog. I apologize for that, but I would try to keep him quiet. So just a little bit of background on the Decarbonization Symposium. The School of Architecture Housing Consortium was formed in 2019, which seems like an eon ago now. And the idea had been that within the school, we have a great deal of expertise, both in housing design and housing policy, and that if we could bring everybody together, we could establish a pretty powerful think tank on those topics. And we also brought in, over time, other experts from outside, and we set about addressing some of the major issues on the issue of housing. First of course, the right to housing, the ethical and political imperative around our housing policy and our housing provision, the idea of the right to housing, the issue of climate change, the threat of sea level rise, the necessity for managed retreat for some communities and the policies involved there. And of course, the issue of carbon footprint and the decarbonization of construction, including housing, and reducing the carbon footprint of our housing. And on that latter topic, Meta led the research group, included a number of people in the consortium, Francis Huppert, Chris Cirillo, Varen Brambat, Jared Delane, Zara Kuz, Richard Lee, Radi Majmudur, Dylan Baker-Rice, and EJ Song, some of whom I think are going to be on the call today. And in late 2021, we published a white paper policy on all of these issues. And I will put a link to it in the chat later in the talk. So obviously a major chapter is the chapter on decarbonization, and that's the topic that we're going to be discussing today. And of course, although we talk a lot about cars and car emissions, we all know that buildings are a lot worse. And one of the major recommendations of the white paper was the idea of adaptive reuse. You know, keeping an existing building is always more sustainable than demolition and reconstruction. So pay attention, please, the people that are doing the Penn Station GPP, knocking down some perfectly good buildings that could be kept. But on the other hand, we've got $56 billion in new construction every year in New York City. So addressing that issue will contribute substantially to reducing our carbon footprint in the future. And the recommendations coming out of the white paper focused on, among other things, strengthening the building codes. We know about Local Law 97, which is a kind of relatively little understood law that imposes pretty strict carbon emission standards on buildings over 25,000 square feet. And there are certain targets for 2025, 2030, 2050 to meet those requirements, and non-compliance will result in fines. And the white paper has some specific recommendations about strengthening Local Law 97 and making sure that we can achieve compliance. And then, of course, the issue of the extensive use of steel and concrete, very energy hungry materials in new construction, and the idea of mass timber, and why in other parts of the world like Canada and Scandinavia, mass timber in high-rise construction is now an accepted form of doing business and a more sustainable method. We don't seem to have gotten there yet in New York City, and we can and we should. So those are some of the issues that we're going to be talking about today. I'm really looking forward to some of the contribution from the speakers, and I will hand it back to you, Meta. Thank you.
Thank you, David. That was excellent. I would like to let everyone know that I'm joined by my co-moderator, Fatou Jabi. Let me briefly tell you about Fatou. Fatou is a sustainability consultant and senior account manager at the New York City Accelerator. She provides technical advice at the Mayor's Office of Climate and Environmental Justice's New York City Accelerator program, collaboratively working with building owners, decision makers, and their teams to comply with local laws and implement cost-effective deep energy retrofits and smart technologies in buildings. She holds a Master of Science in Sustainability Management from Columbia University and a Bachelor of Science in Computer Science from Kentucky State University. Welcome, Fatou. Can you unmute yourself?
Yes, I have. Thank you so much for the introduction, and good morning, everyone. I'm also very excited to be co-moderating this symposium with Meta, and I'm going to share a little bit of a background on her as well. Meta Bronzima is an architect and urban designer committed to sustainability, equity, and design justice. She practices architecture with the Collective for Community, Culture and Environment LLC, an all-women-owned consultancy based here in New York City. Meta is an adjunct professor, associate professor at Pratt Institute, where she leads the Pratt Housing Consortium Decarbonization Working Group. She holds a Master's of Architecture degree from Columbia University. I'll pass it back to you, Meta.
Thank you, Fatou. Without further ado, I'd like to introduce our first panelist, Bill Kaplan. Bill Kaplan is the author of Thwart Climate Change Now, Reducing Embodied Carbon Brick by Brick, and this book was published in 2021. With an engineer's understanding of sustainability, a passion for people-friendly building design, and a 34 career in high technology, Bill Kaplan researched the building environment from a human and environmental perspective for more than a decade, contrasting designers' claims with the ecological veracity. Bill holds a Master of Architecture degree from Pratt School of Architecture and a Bachelor of Science in Materials Engineering from Cornell University. Let me now share my screen and we will hear Bill Kaplan.
Thank you, Meta. I need a slide.
How's that? Hold on.
No, full screen. You have to...
I'm just trying. Is it there?
Yeah. Okay. Can you next slide? There we go. Okay. Hello, everybody. It's great to be back at Pratt, even if only virtually. Welcome to the Decarbonization Symposium. Before we begin, I'd like to thank President Brone and David Burney and for shining light on the urgent, did I go out again?
No, you're there.
It's probably gonna, okay. For shining light on the urgent need for decarbonization. And thank you and Pratt's Housing Consortium for inviting me to address this important symposium.
Bill, are you there? Bill, are you there?
I would suggest that Bill kills his video because it might help his bandwidth a little bit. We don't need to see his face, only the slides, right?
What are you seeing on your screen right now?
We
Okay.
see the decarbonization
That's
slide.
good. Bill Kaplan just entered. He must have been.
Yeah, I think he got kicked out. He's probably back in again.
Needs to refresh his browser.
I keep getting kicked out. Can you hear me?
Yeah, I think that's better. I think
Yeah.
if you keep your video closed, you might not use so much bandwidth. So
I thought Meta was sharing screen.
It shouldn't be a problem. All right, let's try. Okay,
we
so
can
let's.
hear you, we can see the screen. So
Okay, good. All right, let's begin with a little background material about carbon emissions and the meaning of decarbonization. Slide, please. Oh, Maida.
Yeah,
Okay.
I have this
Yeah.
one.
Yeah, one more. Okay. There we go, that's it. In the early 1900s, for the first time in over 300,000 years, the concentration of carbon dioxide in the atmosphere exceeded 300 parts per million, that's ppm. Slide, please. Here we are 100 years later, and atmospheric carbon has reached 420 parts per million, 116 added since 1922. Next slide, please. In the 100 years prior to 1722, the increase was minuscule, just 2 parts per million. That was followed by a mere 7 through 1822. There was a slight uptick after the Industrial Revolution in the late 1800s, adding a total of 20 parts per million through 1922. But then it accelerated with an increase of 116 parts per million, reaching 420 this month. 100 parts per million were added in just the last 60 years at a rate we now know to be alarming. And with it, global warming followed suit, which we now know is its effect. Slide, please. Maida? Yeah. It was also 60 years ago in her book, Silent Spring, that Rachel Carson stated so presciently, the most alarming of man's assaults upon the environment is the contamination of the air, earth, rivers, and sea. That was 1962, and Silent Spring became a catalyst for the modern environmental movement. Its release spawned grassroots activities across the country, a new awakening that led to the first Earth Day on April 22nd, 1970. This year marks the 60th anniversary of Silent Spring, and today marks the 52nd anniversary of Earth Day. Yet to this very day, we continue to assault our environment. Rachel Carson was referring to the massive use of pesticides. She noted the irony that man might determine his own future by something so seemingly trivial as the choice of an insect spray. Today, something so seemingly trivial as the choice of a building material might determine our future, or as trivial as a material aesthetic. Next slide, please. An aesthetic such as this one, concrete, for an architecture school no less. The Architects newspaper reported that the design was meant to be a teaching tool to inspire future architects, to showcase the basics of modern construction and sustainability. The building is even LEED certified, conveying an aura of sustainable design. Slide, please. To be fair, the design addresses the sun's position during the hottest months with a 25-foot roof extension to shade its glass facade. It's true, I'm sorry, next slide. It's true that the mass of the concrete helps to maintain interior temperatures under a hot sun. The 25-foot overhang in Florida's climate may well be a valid sustainability appendage, but not when constructed from concrete, including the entire roof and some of the walls. Sustainable design features do not negate nor justify carbon emissions from the excessive use of concrete, emitted in bulk before the first student entered. This is not unique to the University of Miami School of Architecture. Many architecture schools, as well as institutional, commercial, and residential ventures, are styled with a concrete aesthetic. Did we forget that manufacturing cement produces 7 to 8% of the world's energy-related carbon emissions? This is the opposite of decarbonization. It's time to wake up. Next slide, please. This is what global warming looks like, what we are facing. For the 2,000 years prior to 1900, temperatures remained within a plus or minus quarter degree bandwidth. But since 1900, they have increased more than 1 degree Celsius. Notice the sharp rise since 1970, and nearly half a degree change since 2000. If this rate of increase is not curtailed, holding to even a 3 degree rise, to slow down this rate of increase, we must decarbonize. But what does decarbonization actually mean? Next slide, please. When we speak about reducing emissions, energy and its consumption typically come to mind. This means switching to low carbon and no carbon sources and reducing the amount of energy we consume. Although achieving carbon-free energy worldwide is the ultimate solve-all, it is a very long-term proposition, one that requires political will, funding, and time. Slide, please. Reducing energy consumption relies on the use of energy-efficient appliances and designing energy-efficient buildings. Energy-efficient appliances and equipment are the low-hanging fruit, merely a function of budget and availability. This is not particularly taxing to an architect's design. Designing energy-efficient buildings or retrofits is a more difficult task. It is an art form that requires engineering finesse. But these solutions by themselves address only half the equation. They only address operating emissions. They ignore their own carbon footprint, the emissions generated while fabricating the materials and equipment, and those generated by constructing buildings and infrastructure. These are the embodied emissions. So how do these sources of carbon emissions, embodied and operating, relate to each other? Slide, please. That's simple. First, you mine, harvest, process, manufacture, transport, and assemble or construct. Then you get to use it. Embodied emissions are upfront.
Industry is clear-cutting woodlands that are an important.
Uh-oh. Thank you. Embodied emissions are upfront. Operating emissions come later over time. Unfortunately, embodied emissions are released way before any product is purchased, before any building is occupied, before any infrastructure is used. They accelerate warming in real time, way before any benefit from energy efficiencies can even begin to accumulate. It can take a decade or more of operating gains to merely offset their upfront embodied emissions. As this graph indicates, over the next 5 years, 70% of the carbon emitted from new buildings will be embodied carbon. 10 years out, embodied emissions will still be the greatest share, equating to 60% of the total. Embodied emissions are the first tally of sustainability. Operating emissions are the second part of the equation, which brings us to the purpose of this seminar, to discuss the challenges and opportunities to decarbonize the built environment. Slide, please. Decarbonization is not just a good thing to do, like buying green, nor is it just an academic exercise in sustainable design. To understand the challenge and the opportunities to decarbonize, we need to know the facts. The facts matter. How many tons of carbon can we continue to emit before warming gets out of hand? How many tons are we emitting now? What is the status of our decarbonization? What is the timeline? The answers can be found in these two reports, Climate Change 2021 from the IPCC and the Emissions Gap Report from the UN Environment Program. The emissions allowable to stay within the 1.5 to 2 degree targets can be found in Climate Change 2021. Let's take a look. Next slide, please. This table addresses the remaining carbon budgets, the volume of carbon emissions allowable until net zero is achieved. Net zero means carbon emissions can be no higher than the amount of carbon freed from the atmosphere. Calculated from the beginning of 2020, each emissions allocation is tabulated with its likelihood for success from 17 to 83%. Given the consequences of continued warming, an 83% shot is the minimum we should shoot for. Would you bet the planet on anything less? To hold warming to 1.5 degrees with 83% probability allows 300 gigatons of additional CO2 emissions. That's cumulative from the beginning of 2020, 300 billion metric tons until we achieve net zero. Defaulting to the 2 degree target, we can triple that to 900 billion metric tons. That sounds like a big number, but how much do we actually emit each year? Slide, please. Maida? 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 Uh-oh.
I think she might be having issues. Let's just give her a few seconds.
Yeah, okay. Murphy and technology don't work well. So,
Letting her back in right now.
okay.
Okay. Thank you.
Hi, everyone. Can somebody enable the screen sharing, please?
Yes, give me one moment. Let's see.
Sorry about this interruption.
Okay, you should be able to do so now.
Okay. We are here. Can you all see the screen?
Is loading, but yes.
Okay, one more slide.
Okay. We're going to the next slide now, Bill?
Yes, yes, please. There we go. Okay. This is a graph of our annual CO2 emissions, the basis for calculating the carbon budget. Fossil CO2 emissions, bright purple, make up the bulk. The rest are from land use. Their total has exceeded 40 gigatons per year for nearly a decade. If we at least maintain this range, what's the prognosis? Slide, please. At 40 gigatons per year, we will exceed the remaining 300 gigaton budget for 1.5 degrees in 2027, only 5 years from now. And with it, our 80% chance of success. We will exceed the 900 gigaton budget for 2 degrees in 2042. Yet net zero targets from the world's largest emitters are 2050, 60, and 70 at best. So let's see how our transition to carbon-free energy from renewables is coming along. Slide, please. When it comes to renewables, like solar and wind, and for electrification, we are fed a lot of hyperbole about record growth, but numbers without context can be deceiving. Let's start with electrification. 26% of the global electricity consumed in 2019 was generated from renewables. 26% is fantastic progress, but here's the catch. Next slide, please. Electricity accounted for only 17% of total final energy consumption worldwide. In other words, electricity from renewables was 26% of that 17% share, a mere 4.4% of the total energy consumed worldwide. Slide, please. It's a similar story for heat as well as transportation from renewables. In 2019, total energy consumption from renewables worldwide was only 10.7%. But unfortunately, one of those renewables is not carbon-free, biomass. Next slide. It may surprise you that biomass is the largest source for renewable energy. Biomass fueled 40% of all renewable energy in the United States in 2019. Per BTU of energy released, biomass carbon emissions are actually worse than oil, and they're 40% greater than natural gas. Biomass energy generated 350 million metric tons of carbon dioxide in the US alone in 2019. Biomass energy consumption was twice hydro, twice wind, and 5.5 times solar. So how much of our energy is really generated from carbon-free renewables? Next slide, please. Total carbon-free energy generated in the United States in 2019 constituted 14.9% of energy consumption. But 57% of that was from nuclear. Carbon-free renewables constituted a mere 6.4% of total US energy consumption. While reducing emissions has been a priority for more than 20 years, we continue to look to the future, relying on the future decarbonization of our energy supply, on future electrification. Our journey to net zero will take a lot longer than advertised. We are not well on the way to decarbonization. Slide, please. In every other area of potential decarbonization, we are not doing enough. Regardless of all the green certifications, fawning articles in the press, and architecture competition award winners, with 40% of all energy-related emissions worldwide coming from the construction and operation of our built environment, we cannot wait for future decarbonization, a time frame based on wishful thinking. We must step up to the plate. Next slide, please. This is why I spent the last 3 years writing Thwart Climate Change Now, Reducing Embodied Carbon Brick by Brick. Embodied emissions from construction materials and design methodologies have altered the picture, altered the nature of the challenge. They must be factored in framing every policy and incentive, even for materials and products manufactured elsewhere. Climate change knows no borders. CO2 emitted elsewhere impacts the climate in New York. Slide, please. Now means over the next 5 years, 2022 to 2027. This is key to make over the next 10. We must buy time now by focusing on embodied emissions, by not taking them for granted as a necessary fact of life. Operating savings can depend on the weather, the economy, good practices, or the occupant's functional choices. They can also be improved upon in future years. This is not so with embodied emissions, which are locked in up front. Already emitted, they cannot be mitigated. Reducing new embodied emissions can be addressed immediately with the next building or infrastructure designed. There are two paths to cutting embodied emissions: top down and bottom up. Top down are through policy, legislation, and building codes, like New York City's Local Law 97. Bottom up is through the material choices of the 1.3 million architects worldwide, like using wood or low carbon products. Both paths are essential. But while we wait for the new building codes, policies, and legislation to be activated, architects worldwide can start cutting new emissions this year by something so seemingly trivial as material choice. If you are a student, please mention this in seminar or studio. If you teach, please teach it. If you are in practice, please apply it. If you are a policymaker or a legislator, please weigh embodied carbon in every decision. If you are an activist, please push for it. I urge you to do so, and thank you.
Thank you so much, Bill. That was an excellent presentation. I'm going to stop share right now. I would like to urge all of our listeners to note their questions and put them into the chat. We will be taking questions and fielding questions. So please, 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 during the presentations, write down your questions and put them into the chat. So let me share my screen here. 1 second. Hold on. Screen. Can you see, what do you see on your screen now?
We see the symposium backdrop.
Okay, sorry. Stop share. See if I can, okay. Do you see a screen with the Earth and a title?
Yes, we do.
Perfect. Okay, I would like to now introduce our second panelist, Dr. Paul Crivella. Dr. Paul Crivella is an American civil engineer and professor at the State of New York College of Environmental Science and Forestry, called SUNY ESF. His research focuses on the areas of mass timber and bio-based products. His teaching focuses on the areas of sustainable construction and construction management. Paul holds agricultural engineering degrees, Bachelor of Science and M Engineering from Cornell University, and a PhD in Environmental and Resource Engineering from SUNY ESF. Paul, please start your presentation. Can you see the first slide of Paul's presentation?
Yes, we can. Meta, thank you so very much. And thank you all. I'd like to extend my thanks as well to the wonderful team at Pratt, Meta, Francis, all of the organizers of this event. I'm really pleased that we're able to join together and look at this issue from a number of different perspectives. So I'm pleased to bring a perspective today from the SUNY mission-driven institution for environmental stewardship, the College of Environmental Science and Forestry in Syracuse, New York. Our institution is working on a number of fronts to help New York State transition to a more sustainable future, including, in my work, a bio-based economy. All of this essentially helps us to integrate into the overall state plans from the Climate Leadership and Community Protection Act in building ourselves a future that I think was pretty clearly laid out in Jim's presentation is the future that we deserve as New Yorkers and we need to leave for our children. So with that, could I have the next slide, Meta? So let me talk a little bit now about how we view the future of carbon-based impacts of our construction practices. And those carbon-based impacts include carbon-based impacts for both new and existing buildings. And so I'd like to start the talk about what the future for existing buildings looks like with a brief description of the recent history, if you will, of mass timber. And so mass timber construction was a project that was taken on in the late 90s in Europe to help understand if the forest resource could become essentially the key source for the structural systems in the future buildings being built in Europe. But it really came into the public perception in North America with a rather iconic project that was done in 2009 in London by Andrew Wall of Wall Thistleton Architects. And it was called Stadthaus. And it was an 8-story building. And it addressed kind of the future of construction in a number of ways. Inherently, it addressed the future of construction in recognizing that it needs to be a future that includes carbon as a storage component in the buildings themselves. And so it was a mass timber building. On the right, you're looking at the inside of what are referred to as cross-laminated timber panels. The total construction was a set of cross-laminated timber panels that were manufactured and customized offsite and then brought and assembled to site. The assembly itself of the 8-story building structural system had a 27-day duration, and it required 4 carpenters working on site during the process. So not only did this building represent what was potentially the future of construction materials, but it also represented a significant change in terms of the fabrication and delivery of construction projects. And so with that, really across the AEC industries, people started to delve into and consider potentially what are the aspects of this new approach, this mass timber approach, that we can capitalize on as we think about our future construction trajectory. And so Meta, could I have the next slide, please? And so sure enough, it began to pop up in the popular press. There were a number of aspects of it that seemed to capture the public imagination. And Meta, you can go ahead and keep advancing, I think 6 more times. And so people who knew I was working in this began to say, hey, I've seen this in this publication and that publication. And sure enough, over and over and over, it seemed like popular opinion had moved to recognizing potentially there was going to be a different future for the way we built our buildings. And so the next slide shares that as well. And yes, and so this future essentially combined a number of attractive components for how our buildings were to be built. And so significantly, large corporations that had made commitments to sustainability recognized that part of that commitment to sustainability would include the way that their built environment impacts were controlled. And so next slide. And one more click. So in announcing its new corporate headquarters being built in Bentonville, Arkansas, Walmart not only made a commitment to actually using forest products as the materials for construction, but also helping develop a regional forest economy within the state of Arkansas and beyond. Next slide. For Microsoft's new headquarters, as they build out their campus in Sunnyvale, they've recognized that all of the buildings will contain mass timber. This is mass timber panels, you'll note, used in a hybrid system. But they recognize potentially the ecological benefits of using forestry products in that regard. Next slide, please. A software development company in And Australia has decided that their commitment to net zero carbon will begin with building their next headquarters, having significant amounts of mass timber. And next slide. And so Adidas projects as well, okay, their recent headquarters addition recognizes that they're building their future with mass timber, and it's coming in a regional basis. So as we can see, all of this indicates that mass timber has captured the public imagination. It's become the darling of the popular press. And what we'd like to do and ensure at ESF is that the future construction trajectory of using this material is done in a truly sustainable manner. And so with the next slide, we're going to begin to discuss exactly what that looks like. So this is a slide from a wonderful book in regard to using carbon capturing or sequestering materials in our construction put together. And so this shows a study that was done by the engineering firm Arup. And what it's showing on the left, you see an axis that indicates that the lines above the x-axis are times when the building construction process is emitting carbon. The line below the x-axis indicates times when the building construction process is able to capture carbon. And so there's a comparison here between an identical building, one built with a reinforced concrete structural system, and that's shown as the dotted line to the top. The other is the solid line below, which shows the potential carbon impact of a mass timber building. And so what I'd like to do is sort of take us through the steps here of the way the comparison plays out when we look at these two construction approaches. You'll notice all the way over on the left, the process of carbon sequestration. Next, Meta. During this growth phase in the forest is a key principle that fundamental to considering the environmental benefits of mass timber construction is really understanding and being able to optimize the way that the carbon impacts of the forestry practices are done. You can see the huge drop or carbon sequestration that we get from that. To the right of that, you'll notice that both for reinforced concrete as well as mass timber, the lines begin to rise, but there is a more substantial rise in the case of the reinforced concrete building. So there's an additional benefit from mass timber construction, and that comes about due to the reduced carbon required for fabrication of the products as opposed to the carbon invested in creating Portland cement and the rest of the concrete components. We refer to the second advantage as substitution benefits. So sequestration, what happens in the forest, and then substitution, the change in processes, are both considered when we consider the overall impact of carbon processes. However, there's one other significant potential impact of this total approach. And so next, Meta, if you could give me 2 additional clicks. Okay. You'll note that there now appears a new dotted line in this process, and that's a mass timber building, but a mass timber building built where sustainable practices aren't followed. And you notice that the sequestration is nowhere near as significant as the baseline building, and the manufacturing doesn't provide as great additional benefits. And so we end up with a timber process, a delivered building that is no longer carbon negative, but rather the structural system, in fact, is not as beneficial as it could be. That difference is an important difference, and I'll talk a little bit about what we're doing to make sure that we're moving in the right direction in that regard. The blue oval on the right is the end of life. And so this is something that we believe is a significant opportunity as well. It was pretty clear from the layout of where we're headed in terms of carbon that it's not enough to just think about what we're doing initially with embodied carbon nor operational carbon. We really need to view the future that we're leaving for our next generations and ensure that we're leaving them the opportunity to continue to enjoy what we've been able to enjoy with the natural environment. So at ESF, for new construction, we focused very closely on this initial stage and this final stage for our current research. So with the next slide, I'll begin talking a little bit about what we're doing with that initial stage. So what is happening at a forest level, in particular, what's happening at a forest level when we think about our New York State or our regional conditions? And so you'll notice the graph on the right shows that there's actually a number of different carbon fluxes. The dark line that heads up off to the right and diagonally indicates that year over year, our forests are very effectively capturing and sequestering carbon in the biomass that's available. When harvest time comes, you'll notice that that sequestered carbon drops significantly as we remove it from the forest stand. There are residues that are left in the forest. And so you'll notice that darker green swoosh down to the right indicates that those sit on the forest floor and release carbon for a period of time. And then there's a period of time just after that, during which the stand takes to recover. As the new seedlings are planted, forests begin to grow, the rate of carbon capture is not as rapid as the rate of carbon capture of a more mature forest. So to really understand our impact in the forest, we've got to begin to break down and understand sort of what is it that we're working with when we think about New York State forests. So over on the left, you'll see a couple important notes. In no case in New York State do we really have what we would call old growth timber remaining. The late 1800s, early 1900s saw New York State essentially denuded of forest land. We were down to less than 20% forest cover. From that time, we've recovered, and today we're up over 60% forest cover in the state. However, that has actually not been uniformly planted. And so we end up with a very interesting natural replacement activity in succession that results in forests that have mixed species of trees in the forest. We have both hardwoods and softwoods, and we have a wide variety of each of those. We also have stands that are not uniform in age. And so unlike forests in the far north of Canada and in the southeast of the United States, where there are large uniform age populations, our forests look very different. We've got mixtures of species, and we also have mixtures of age. Harvesting from our forest is really going in and selecting individual trees on a basis to create these products. So next slide, please, Meta. So what does it look like when we begin to think critically about New York State forests? So we'll divide up the forest resource into both softwoods and hardwoods. And on the left, you see there's some descriptors of one of the most, or the most common softwood species in New York State forest, and that's eastern white pine. These trees actually were characteristic of distinguished New York State forest for centuries. The initial colonization of the United States included an interest by the British Navy in coming to the forests of the northern United States to harvest eastern white pine because of their size, stature, and their ability to be used effectively for creating masts for British warships. So what we're talking about here is a species that's been long established in this region. We've got over 10 billion board feet of this timber. And most importantly, under current harvesting practices, as each year we remove 1 unit of biomass from the forest, nature is replacing that annually with 2.6 units of additional growth. So we actually are currently using our forest in the exact manner shown on that previous graph, where year over year, they are effectively carbon capturing ecological systems. However, if you go out into the forest, you're not just looking at these white pines. There's a mixture of hardwoods as well. And we've selected 3 in particular that have been of interest for our research. The first is black locust, and you can see on the right there, black locust essentially has a range in the lower right. You'll notice that the eastern seaboard of the United States is shown, and there's an array of green and darker green circles. This indicates essentially the range of both eastern white pine as well as black locust. So it's not unusual to find both of these trees in that range. This was actually an introduced species in the northern forest, and we are looking at it because it has very unique properties potentially for making mass timber products. We're looking at a couple other as well. You may have heard that there is an invasive pest, the emerald ash borer, which is causing mortality among about 8% of the hardwoods, which is the percentage that ash trees represent in our hardwood forest. So we're losing those, and we're losing those quickly as the pest spreads across New York State. We want to provide a solution that recognizes that forest dynamic and takes advantage of that biomass potential. And then we're also working with red maple. And so red maple is shown as a hardwood, and you can see in the upper diagram on this slide, that blue area showing mixed ranges of hardwoods there. And so New York State is well endowed with a significant amount of hardwoods like red maple that could be used potentially for products as well. And so Meta, if you will head to the next slide. So to understand what we should be building with, we really want to take what the forest has given us essentially and make sure that we're using it appropriately. So these are micrographs of the cellular structure. On the left, you're looking at eastern white pine, and on the right, you're looking at black locust. Eastern white pine distinguishes itself as having one of the lowest densities of any of the softwood species. Black locust, on the other hand, has one of the highest densities of any of the hardwoods. And so what we've been doing with each of these species is putting together mass timber products that will optimize these performance characteristics. And so Meta, if you can give us the next slide. So traditionally, mass timber panels have been created using a process referred to as cross-lamination. And as you can see here, this requires layers of parallelly placed boards and then subsequent layers that are placed orthogonal or perpendicular to the lower layer. And so this is done typically with monoculture species. So this is done typically with softwoods that are harvested in an industrial fashion. And then using industrial thicknesses and supply chains, these products are currently what dominate the mass timber construction industry. If you'll go to the next slide, Meta. We've been looking at both cross-laminated timber as well as diagonal cross-laminated timber, or DCLT. And in this instance, what you'll note is that the subsequent layers are not all laid in a perpendicular fashion, but actually we're able to consider the properties of the material, both in terms of its strength and its dimensional stability, and shoot to optimize the way we're using the fiber in the final product to give ourselves improved performance over CLTs. And so just to help you all sort of wrap your heads around what that might look like, I'll just show you a quick video, Meta, if you would. And yes, so if this plays, you can see, okay, what you're looking at is panels that are made with hardwood, black locust, outer layers, outer lamina, and then inner lamina, diagonal lamina of softwoods. And we're showing that the performance of these panels actually exceeds by anywhere from 30 to about 60% the performance of current products on the market of equal thickness. So although we don't have today a large industry in New York State producing these products, we've been pleased to be able to show that New York State has the resources which can be harvested sustainably to produce products for the future use. And so with that, what I'll do then is just touch on a few. I think I'm running up toward the end of my time. I'll touch on just a few other efforts that we've got at DSF. So Meta, the next slide. So we've been looking at what will happen at end of life. And really there's a couple key things that we should be doing now with mass timber construction to assure that we've got the opportunity for end of life resurrection, as we'd like to call it. And so those include capturing the information during the design and construction phase. We want to ensure that the architects understand exactly what's available, the engineers know the material properties, and the builders understand the construction processes so that they can put together accurate bids when the time comes for deconstruction. We're incorporating biologically based structural health monitoring systems. So these are indicators made with biomaterials that will be able to show the structural history of the panel and ensure architects have confidence that it hasn't been damaged during its use. And then at end of life, we're developing methods to use automation, as we recognize the future will probably allow for less and less labor to be used. We're ensuring that automation will be able to be used efficiently for the separation and deconstruction of those materials. And so with that, that really wraps up our current work in regard to new construction. I'll just touch briefly. I think Gabrielle will be sharing quite a bit about the potential for renovating existing buildings. And so I'll share that we've been working on a project that's built around a bio-based retrofit cladding system. And so you'll note on the right, we've got a thin 1.5 inch CLT panel as a substrate, and then we've got a wood fiber insulation product overlaying that. And next slide. And so these panels can be fabricated at scale. And as you note in the diagram shown, okay, in the middle left, wood fiber insulation, a product commonly used in Europe and about to be produced regionally in the Northeast and Maine, starting in 2023. Wood fiber insulation is the only insulation product currently that is carbon negative throughout its manufacturing process. And so the panels, if you'll give us the next slide, provide all the functions of envelope. And then if you'll provide the next slide, Meta. Being a bio-based material, we're very concerned about its long-term durability. So unlike petrochemical products, this bio-based product has the potential to, when installed, offset 6 years of energy savings for the building. So the panel installed in the building will provide a year of energy savings for each year that it remains on the surface of the building, but the embodied carbon captured in the manufacture and application of the panels to the exterior surface of the building can provide an additional 6 years of energy savings for the building. So we want to ensure that potentially this path, if provided, will have long-term durability. And so we're moving toward mock-up scale production and modeling of this as we move ahead. And so with that, I think, I hope I've given you a pretty clear picture of how we're trying to work in concert with the forest and ensure that we're doing right by what nature has given us to work with as a building material that embodies carbon. I apologize. I think we'll have questions at the end if I'm not mistaken.
Correct.
Yeah.
And please, attendees, please write down your questions and put them into the chat as you think of them. Right now, I'd like to introduce our third panelist, Gabrielle Brainard. Gabrielle is a visiting associate professor at Pratt, undergraduate architecture, and principal of Fabric First, Architecture and Consulting PLLC. Her current project addressed the challenge of decarbonizing the built environment with a focus on the building envelope and the existing built context of New York City and state. Research projects include a feasibility study of high performance retrofits, multifamily housing in New York State funded by NYSERDA, and an architect's guide to envelope retrofits funded by the AIA Upjohn Research Initiative. She's a certified Passif House consultant, designer, and trainer. So let me just stop share right now and reshare 1 second. One second. Can you all see my screen?
Yes.
Yes.
Do we have full screen on this now? 1 second, it's coming up. Gabrielle, can you see it?
Yes, great. Thank you so much for the introduction, Meta, and thank you to Meta and the Housing Consortium for the invitation. I'm going to speak this morning briefly about a book project that I'm working on with my research partner, Nina Sharifi, who's at Syracuse, another contribution from a little further north in New York State. And so we're working on this book project that grew out of a 2019 AI Upjohn grant that we received to produce an envelope retrofit guide. And this is basically going to be a collection of case studies of successful retrofits with a focus on the details of the building envelope. Next slide.
Let me see. Yep.
So I'll go briefly over the project background and context and then just share a couple of the case studies, which I think are all actually from New York City, from Brooklyn and Manhattan. So why envelopes? So first of all, we're architects. I'm a building envelope specialist, and we have a kind of inherent interest in envelopes and construction details. But we also felt like the existing conversation around retrofits, which has really gained steam, particularly in New York with the passage of Local Law 97, there was just a lot of conversation about mechanical systems, and that's understandable that those feel a little bit easier to retrofit. Often they have equipment that can be, to some extent, plug and play. And dealing with the fabric of individual buildings, where each building is kind of a snowflake, just feels a lot harder. So we felt like there hadn't been enough conversation about these fabric upgrades. And one of the challenges is that if we are going to electrify mechanical systems, we have to do something to the fabric to reduce it, to basically deal with efficiency. Otherwise, we're going to be looking at putting in, hugely very large electrical systems trying to meet the same needs as our current fossil fuel based systems. And it's not, the math is kind of not really going to pencil out. So the fabric upgrades and the mechanical systems kind of have to go hand in hand. And we felt like this is a really great challenge to architects, and that there wasn't maybe a lot of capacity within our community of designers to actually tackle some of these projects. So that was sort of the goal of the that's the goal of the book, is to kind of spread that knowledge. Next slide. So this is probably of no surprise to this group. Buildings are a big part of energy use, particularly in a place like New York City. Our state has these very ambitious decarbonization goals. We say we're going to reduce energy use from buildings by 40% by 2030. That's really soon. And decarbonize by 2050. Most of the buildings that we're going to need to use to meet those goals already exist. So it's really critical that we address this existing fabric in order to, if we have any hope of achieving these targets. Next slide. There are a number of existing resources on retrofits. This is something that the DOE has been working on for a while, through its Building America program. That program is really focused on single-family housing. When you look at those publications, they are very focused on spray foam as the solution. So it's starting to feel a little dated now that we're having a more sophisticated discussion about embodied carbon. But it's important to acknowledge all the research that has gone on there. There's a number of city and state NGOs, not just the excellent Beeks in New York, but also Mass Save in Massachusetts. There's some interesting efforts also in Maine, Nova Scotia, folks who are kind of pushing this on the policy level. Their recommendations tend to be more policy driven and less kind of the nuts and bolts of details that architects are interested in. And then there's a lot of material out there from industry, which is great, but we need to acknowledge that a lot of that is typically biased towards a particular system or typology that folks are trying to sell you. So for example, there's a great retrofit guide from particular group of insulation manufacturers, and every detail has the particular insulation that they're trying to market. So it's important to think about where the information is coming from, and our interest was into producing something that was basically not kind of sponsored content. Next slide. So our guide in this, one of our things that we're kind of hoping to emulate, is this really excellent book by Alison Kwok, Don LeCorner, and Jan Fillinger for passive house details. This is for new construction. But the focus is really on producing these high quality, very clear drawings of architectural details, and we felt like doing something like that for retrofit could be potentially very useful. Next slide. So the way that we've organized our thinking around this is around housing typologies. And one of our observations is that, if we look at historical development in the United States, we have a number of very similar typologies based on the materials that were available at the time that that many of our towns and cities were built. So we see that we have common building types ranging from Maine to Minnesota. And these are buildings that are at the vintage that they're, likely in need of retrofit. Many of them have probably been retrofitted or changed a little bit already. Next slide. And our thinking about typology, we kind of broke it down by structural material, vintage, and size. We did some research for NYSERDA, where we kind of went into this in more detail for New York State. But basically, we're looking at wood frame buildings, masonry buildings, and you can see that there's some differences, particularly when we get into post-war mass masonry or transitional masonry buildings, where we have very large developments of buildings that are all very similar, which is a really interesting opportunity for retrofit.
Lori,
Next slide.
I thought you were scuba diving somewhere.
And then, it's really important to be cognizant of the building science implications of retrofitting. And I think this is one of the most challenging aspects. You can get into a lot of trouble if you create a highly insulated building without dealing with other aspects of building science, particularly airtightness and ventilation.
Oh, no.
So this is something that we're going to deal with on a case-by-case basis. In the book, it's sort of hard to address something as complex as building science as a kind of as a guide, but it's something that will be specific to each case study. Next slide. And the basic thinking of how do we affect these retrofits, you can kind of insulate on the inside, insulate on the outside, or do a little bit of both. And we're going to dive into the case studies and see some examples of these strategies. Next slide. So I'll go through a small, a medium, and a large, looking at wood frame, masonry, and also some combination of kind of brick and block, all from New York City. Next slide. So when we're dealing with these small wood frame homes, these are, as some of you might know, we actually have a number of these in Brooklyn. Next slide. The options are sort of to try to insulate inside between the studs, or to remove the cladding and apply insulation and air barrier to the exterior. Obviously, there's many different materials that you might consider for this. We're going to see an example using, I'm not sure if it's mineral or wood fiber. Next slide, please. So this is a case study from Dimmest Park by Duncan Architect. This is actually a historic district. The existing building dates from, I want to say, the 1920s. It actually ended up with asbestos shingle. Yeah, I believe this house was built between 1902 to 1914. Next slide. So the architect made the decision to retrofit this to Passive House standards, and basically did a complete gut because there were other things that needed updating on the interior of the building. But they basically removed the cladding, installed new control layers and insulation, and then replaced the cladding and maintained the the appearance of the historic district, which can get a little bit challenging because if you're adding insulation on the outside, you're actually changing the geometry of the building itself. Next slide. Another example, this is a really interesting one of pre-war masonry. So New York City has a lot of mass masonry buildings, let's say 6 or 7 stories or less. Many of these are co-ops. And this would also apply to row houses. Next slide. these strategies would also apply to row houses, but again, you kind of have the option of adding the insulation and air tightness on the interior or doing it on the exterior. Often in these brick buildings, putting it on the interior can be preferable to if there's ornament on the outside that you want to preserve. On the flip side, putting it on the exterior would help out if you've got really tight interior clearances where you need to maintain, minimum room sizes and that sort of thing. Next slide. This case study is again in Brooklyn, also in Dimmest Park, of a co-op. Where the co-op actually had control over a couple of units that had been rentals, and one of those units was vacated, and they decided to do a kind of standalone passive house level retrofit of this unit. So next slide. So basically, they basically encapsulated this unit. They insulated the interior of the brick wall, and they also put insulation and air tightness in the ceiling and the floor, which is great for sound insulation as well. Prior to adding the mineral wool insulation, they did a liquid applied air barrier on the brick. Next slide. And then this is kind of some construction photos, and then an interior vapor variable control layer and new mechanical system. So this particular unit now has its own ventilation, heating and cooling system separate from the building. Really interesting approach. It kind of gets at the challenges of what do you do in a co-op where you've got a lot of folks that are tenants or owners who are not easily moved or displaced during construction. You might have to do units one by one. Next slide. And the last example is a large, again, a co-op concrete and masonry building on the Upper East Side of Manhattan. Next slide. So again, the choice to insulate either the interior or the exterior. Next slide. This particular building is being renovated by Rogers Partners, and they had a lot of issues with deteriorating brick. So they had brick falling off. It was an issue for FISP, formerly known as Local Law 11. They had kind of a permanent sidewalk bridge, and then Local Law 97 came along, and the co-op said, okay, we've really got to do something about this because this is not, sustainable financially for us. We need to stabilize this facade, and we need to deal with the potential fines that are coming down the road with Local Law 97. Next slide. So this is some issues of the deterioration of the brick. Next slide. A lot of these buildings, unfortunately, are poorly constructed, and we're kind of seeing the results of this, 50 years later, 60 years later. The co-op made the decision to remove the brick, essentially take it back to the concrete block, install exterior insulation and new cladding system. So it's basically a rain screen system. Next slide. And it's a ceramic tile rain screen. So they totally changed the look of the building, in addition to dealing with some of the issues they had with the facade deterioration. And interestingly, they didn't update the windows. They kind of did a very careful cost-benefit analysis of this because the cost was being borne by the building owners, the co-op members, many of whom were on fixed income. So I think this highlights some of the challenges also of how do we actually retrofit these large projects, and how do we finance it? Because a lot of folks are not in these co-op buildings in particular are not, planning on these major renovations as part of their capital plans. Next slide. So just a kind of a teaser, this is a project that a lot of you may be aware of that's just started to be publicized by Cycle Architecture and Planning that was funded by NYSERDA to do large-scale retrofits of NYCHA projects. So as I mentioned earlier, there's a lot of examples of not just in public housing, but also in the private sector of these really large campuses where there's multiple buildings, often mass masonry with repetitive construction, and they are a great candidate potentially for an exterior retrofit that doesn't displace the residents, And one of the things that cycle architecture is looking at is, can we also use that as an architectural opportunity to actually change the look and the appearance of these buildings? So I don't have details. This is something that will definitely be included in the book, but I just put a rendering here to kind of, as a bit of a teaser to have people think of some of the potentially inspirational potential of retrofits in New York. Thank you so much.
Thank you so much, Gabrielle. That was fascinating. So as you may have heard, we have scheduled a short break after Gabrielle's presentation. So I would like to shorten that break to maybe 2 or 3 minutes.
Okay, sounds good. Hey, Jerry, congrats.
So please just go and get yourself a cup of coffee or water, and we'll be back in about 2 minutes. Okay, thank you. Hey, Patrick. Okay. 1 second.
You have to unmute yourself. unmute yourself.
So welcome back, everyone. I hope you all had a nice break. I would like to now introduce our fourth panelist, Werner Morath. Werner is a registered architect and principal of Brooklyn-based architecture firm Loading Dock 5, which he co-leads with the certified passive house consultant Sam Bargetts. Loading Dock 5 has pioneered the design of mass timber projects, notably Frame 283, a 5-story residential building with commercial spaces in Brooklyn. Werner studied at the Architecture in Europe at l'École d'Architecture de Paris in France and at the Technical University in Vienna, Austria. He's a registered architect in the state of New York. Werner, take it away.
Thank you, Maida, for introducing me, and thank you for inviting us. Also, I wanted to thank Bill to creating such awareness about embodied Kaplan, because I think that's an issue I think a lot of designers and architects were not aware of until recently, and it's definitely a pressing issue that should be addressed. Sam and I, our office is focused on sustainable architecture, and we try to do our best to reduce operational carbon and I guess in the future now also embodied carbon. The building you see on the screen right now is 283 Green Avenue. It's 10 apartments and 2 commercial spaces on the ground floor. There was an existing building there, so we were able to grandfather the commercial use on the first floor. And the main structure is a CLT, the slabs. Unfortunately, the exterior walls we still had to make out of non-combustible materials. We chose ICF forms, which is basically a 6-inch concrete form with 6 inches of EPS insulation on the outside. So during this presentation, I want to talk generally about mass timber a little bit, what it is, the new New York City building code, which is exciting that it actually will allow CLT buildings beginning November 2022. We were able to build this building because we had an approved code determination to use CLT, which was very good that we had that piece of paper, because during the whole process when the building was under construction, the building department decided, oh, we made a mistake approving this determination, because CLT is actually not specifically allowed to use. And after many meetings with the commissioner, they actually gave us the go-ahead to complete the building. So the next point would be the challenges, and to talk a little bit about the exterior stairs. So what is mass timber? Mass timber is an engineered wood, as we heard from Paul already, which is exciting because it can replace steel and concrete, and because it's engineered, it's more, you can calculate the structural stress it can sustain, and additionally the forests, it is produced out of the not necessarily old growth forests. Next slide, please. So there are a few different mass timber types. The cross-laminated is the most common one. There's the nail laminated timber, the dowel laminated timber, the glue laminated timber and the structural composite lumber and the diagonal towel laminated timber. I think what we have to be aware of that cross-laminated timber may structurally be superior in the way it acts. However, also I think we should think that it is put together with glue, which might have off-gassing, or we don't really know how will glue react in 100 years. The last one, the diagonal towel laminated timber, would be an option to eliminate the glue. But however, there's not too many places out there that actually produce that material. There's, I think, one company in Austria that which is called Holz 100 that produces the materials. So I think we still have a long way to go to make these mass timber materials available for everyone to use, and also the building codes have to catch up to address all these products available, because right now even the code has been amended and will come in effect in 2022 now. It still doesn't address a lot of products that are available, but will make it very difficult to use because it's just not in the code. Next slide, please. So like I mentioned before, that's exciting news that the building code will allow explicitly CLT to use in buildings, going into effect in November 7, 2022. That's a big step, I think, for New York City. And I hope a lot of CLT buildings and mass timber buildings will be going up. The highlights of the code is it has specific provisions for CLT. It's allowed to be used under construction type 4. And there are certain provisions where it will make it possible to use in exterior wall conditions. I put an asterisk there because it's the certain conditions might exclude, for example, our building, the residential building. Next slide, please. That's the next slide. So about the exterior walls, again, I was a little bit disappointed reviewing the 2022 code because, again, the exceptions would not allow us to use CLT in exterior walls. It says not permitted were load-bearing walls inside fire districts. Pretty much all New York City is a fire district, and it's not permitted in certain occupancy groups for R2 buildings, which is a multiple dwelling building, as well as for shaft walls and other things. So pretty much the new code, the building would look very similar than what we designed. The interior partitions can be CLT. The floors must be minimum 4 inches continuous, and roof decks can be only 3 inches. But I think the importance is kind of to understand how codes determine what architects actually can specify to use, and especially in New York City, as soon as you go out of the city, it's a little bit more lenient, and you can actually specify bio-based insulation products. Considering also local law 97, I think that would be a very important part. Are those insulations allowed to be used? Next slide. So our building at 283 Green follows also passive house standards to reduce the operational carbon footprint of the building. It has an airtight envelope. It has fresh air intakes with heat recovery ventilators. It features triple glazed alu-glued windows. The balconies provide shading on the outside. The thermally broken balcony slabs. The exterior walls, like I mentioned, they're insulated with 6 inches of EPS, which I'm not super proud of because I tried to get away from plastic-based insulation products, but it's difficult to find replacements for that. Electric heat pump water heaters provide hot water, and heating and cooling is provided with electric air-to-air heat pumps. So the building is an all-electric building. There's no fossil fuels. Next slide, please. So the challenges I think that will come up in the future is the supply and demand. The code being going into effect soon, I hope there will be a surge of CLT buildings, but there's not really too many manufacturing plants around, especially on the northeast coast, which will bring probably the price up and maybe make it more prohibitive actually to use, because some construction projects to have a budget. Incentives would be good from the government that would promote or offset extra costs that would occur. Another drawback is that there's not too many experienced CLTs installers available right now. Something that probably will change in the future. Another challenge we had was the construction sequencing on our project, because of the fact that the slabs are CLT, mass timber, and the structural exterior walls are concrete, load-bearing walls. We had to construct it in 2 sequences, so we shored the slabs until the concrete walls could be built and then support the wooden slabs. So if we could have used exterior CLT walls, all these issues wouldn't have existed. We could just have a crane, build the walls, build the slab, build the walls, and so would not have a complicated process like that. So Meta asked me, so what do I wish for? So yeah, I wish for CLT walls and exterior walls, because I know the fire department probably has concerns about compostability, but if CLT walls are sealed on the outside and inside with maybe non-combustible materials, they still might perform better than steel because they conduct any heat, and the charring rate of the wood protects the wood from failure. Another wish I have would be that the building code would allow smaller residential structures with one means of egress to be built out of CLT, because currently, if you have a footprint of 2,500 square feet and you build your building not higher than 6 stories, and you construct it out of non-combustible materials, you can get away with one means of egress, which is kind of a big incentive for developers to develop the building with non-combustible materials, because you use a lot of floor if you would have to build 2 stairs, and also it's the cost. So that's, I think the code has a big impact on the design, what can be built and what not can be built. Next slide. So there's a the exterior stairs on 283 Green is kind of a feature we kind of like to use in our buildings because of several reasons. We would try to encourage the residents of buildings to use the stairs, not use the elevator. It saves daylight, it saves electricity, it saves energy, but also it promotes health, exercise, and social interactions of the residents of the building. Next slide. The two exterior stairs are served through the egress balconies. So each dwelling unit is accessible directly from the balcony, but it also has an interior elevator that has direct access to the apartment. I like this photo because it shows what one tenant made out of the balcony with all the plants, and so I think it's really very much needed exterior space for New York City, especially with COVID now, that you can go outside your apartment. You don't have to use the elevator. Next slide, please. And I wanted to thank all our project team, who, from the owner to the owner's rep, building consultants, construction managers, structural engineer. I want to thank everybody that made this project possible. And thank you very much.
Great. Thank you so much, Werner.
Thank you.
I will now introduce our last speaker, Jay Gorman. Jay Gorman is a project executive at FJ Siame Construction. He has worked on projects such as the Bronx Library Center, Donald Judd Homan Studio, the New York Mets Hall of Fame Museum, Grace Farms, and the Roy and Diana Vagelos Education Center. Jay is currently overseeing the construction of a new building for the Studio Museum in Harlem. Jay holds a master's degree in architecture from the University of Michigan and worked as an industrial designer before joining Siame in 2006. Jay is also a member of the Grace Farms Design for Freedom Working Group. Jay, take it away.
Thanks. Thank you, Meta. Do you hear me okay?
Yes.
Okay, great. Thank you. And thank you everyone for joining, and thank you Pratt and Francis as well. I really appreciate the time to show the work that I, along with Siame and the whole team, did at Grace Farms. So if we can go to the first slide, I'll just walk you through this project as a case study of how to use Gluams in a project. So Grace Farms is an 80,000 square foot community center. It's located in Southwest Connecticut in New Canaan. We were hired for pre-construction from 2011 to 2013. We started construction in 2013 and we opened the doors in 2016. So the design objectives for Grace Farms, for both the client and the architect, which was Sana, was to create an open and fluid space that connects the users to the landscape and offers moments of rest and peace. Grace Farms is a community center. They do a lot of charitable work, a lot of outreach, educational programs, children's programs. They do mass on Sundays in a 700-seat auditorium. They serve community dinners before COVID, and now they're getting back into that now that they've reopened after COVID. And they also have a number of art exhibits that are rotating through, and a really interesting one by Allison Schatz right now, if you're finding yourself at Grace Farms. So again, we were the construction manager for the project. Next slide, please. Sana was the design architect. They're from Tokyo, Japan. Handel was the architect here in New York City. Our owner's rep was Paradis. And again, we worked with a number of consultants, including Burrow Happold, Silman, and Front on the glass wall system, which I'll show some pictures of and how that relates to the Gluams. Next slide, please. So this was the initial concept renderings by Sana of Grace Farms. It's set on a 75-acre abandoned horse farm that was slated to be turned into 10 suburban homes, but Grace Farms Community Church bought the property in 2010, I believe, and they had an international competition. for this community center, and Sana won it. And this was the original design. And as you can see from the design intent, Sana was going for an open, fluid, transparent structure set in the hillside, which was very rolling and watershed as well. Next slide, please. So these are some of the early renderings of the interior of the space. As you can notice, the roof appears to be floating with no supports really. There's no interior walls in a lot of the spaces in Grace Farms. They're supported by these small columns that are spaced every 14 feet apart, which you can make out in the windows. But the roof was, they wanted it to look like the words they used were New England porch, the underside of a New England porch, so wood. So we started early on in pre-construction to help Sana and Handel and the owner understand like how to do this. And Gluams became the most obvious choice after some value engineering exercises and budgeting options. And I'll show some of those. Next slide, please. Here's another rendering. This is the gymnasium, which is down on the end of Grace Farms. It's a sunken gymnasium underground, and it's surrounded by gravel on the ground level. And the wood canopy connects all the buildings together. There's 5 different pods, and they're all connected by this large wooden snaking roof. Next slide. Here's just a plan of the sanctuary. Again, it's a 700-seat auditorium used for conferences, lectures. We just had a conference there a couple weeks ago on design for freedom, which I'll touch on at the end. But these spaces that we had to span were over, in some areas, 100 feet from window to window. So from the back of the lectern to the back of the auditorium is almost 100 feet in span, and they didn't want any columns or any walls in that space. It had to be perfect and open and seamless. So that was really the challenge, was to work with Silman Associates and understand what structural systems would perform like that. Next slide. So we went to Tokyo a couple times, Joe Mizzi and the team, and we worked with Sana in their office, and we did a number of parties and concepts to figure out how to make this space work. There were basically 3 design objectives. The glass had to seem seamless, no mullions. The roof had to appear floating, and the roof above it had to appear as one monolithic metal reflective surface. So those are the 3 main things that Sana was interested in. The client was mostly interested in sustainability and preserving the landscape. Next slide. So I think I touched on this. Another part was, again, connections and connections with nature, and of course, work within the owner's budget and schedule. Next slide. Thank you. So we looked at steel as a way to span the 100-foot spans in the sanctuary auditorium. We had 70-foot spans in the other buildings and some smaller ones. So we looked at steel, we looked at steel trusses, we looked at open web joists, and we looked at cladding open web joists or steel trusses in wood. And then we looked at glulam beams, which in 2013, 2012, when we were working on the project, didn't really seem like an obvious option to us, because it was really not done much, especially in the Northeast. It was done in California, Pacific Northwest, Canada, Europe. There were a few projects at Yale that were done with glulam. And so we connected with the group there, and we found our glulam supplier, which is Structurelam, which is out of Vancouver, Canada. For the roof, we looked at metal deck and plywood, or CLT deck. As Werner mentioned previously, CLT deck is hard to source. It's hard to work with the craftsmen that we have in the New York metro area, but also it didn't lend itself to the shapes of the roof. The roof at Grace Farms is, it curves in multiple directions. CLT is really like planks. laminated planks, and you really can't bend it to match the shapes that Sana wanted. So we ended up on a glulam beam LVL structure with metal deck and plywood on top of that, which could then be easily molded to the shapes that Sana wanted for their flowing roof. Next slide, please. So these are some of the original just sketches that we did with Nat Oppenheimer from Silman Associates. We looked at different options for the roof. We looked at glulams with 2x8s in between them, or we looked at glulams, like I said, with CLTs or LVLs between them. And it was all about how do we balance that labor and material, right? CLTs and glulams and LVLs cost a lot, but have a lot less labor. Doing it in traditional framing, like you would a house, has a lot less material, less expensive material, more readily available, but a lot more labor. So we were trying to strike that balance for about a year and understanding what the best option was that would deliver the project on time and on budget. Next slide. So we modeled the entire building in BIM and Navisworks. All the glulam beams, all the connections, all the glass, all the steel, everything was modeled by the design team, Siami, and the subcontractors and vendors. Because everything here is a long lead time, and glulam is a very long lead time, so is the glass that was underneath Grace Farms. We couldn't put one thing up, measure it, make it, order it, and then bring it on. We'd still be building it in 2022 if we did it like that. So we had to roll the dice a little bit, but using them to our advantage to make sure that everything was measured and cut and fabricated off the model. So all the glulam beams in Grace Farms were fabricated off this, what we call the coordinated model for the building. Next slide. So this is just a detail showing the ring beam, which is in blue. That's the steel spandrel beam that goes around all the buildings. The orange is the glulam beam. Those measure 22 inches high by 10 inches wide. And again, they span up to 100 feet long, so a single glulam beam. And connected on the outside of it was the LVL, which frames the porch or the canopy that goes beyond the glass wall for the building. Next slide. Because the glulams were so long, 100 feet in the sanctuary and about 65 feet in the gymnasium, they required to be tensioned on site. So we worked with a company called Tri-Pyramid in Massachusetts, which designed and fabricated king posts and cables that were then installed in the glulams on site, and they were tightened by the rough carpentry company on site to a specification that Silman and the special inspector supervised that. And on the left, you can see a connection of how the glulam beam. These drawings were done by Structurelam, by the way. Structurelam is a great company, and they come in early on in the design assist process, and they want to work with the architects and design this kit of parts. It's really, if you're thinking about doing glulam on any of your projects, I'd highly recommend bringing in the glulam supplier early on, because they're going to play such an integral part to the structural design of the building and help guide that process throughout. But yeah, on the left shows just a kit of parts of how these pieces went together, and Structurelam made the steel, Tri-Pyramid made the connectors that you see there, and a company named Chicago Rolling bent the steel beams in 2 dimensions. It bent it both in plan and then up, but we had to maintain a flatness on the top. Anyway, it created a lot of challenges for that beam to be bent in that way to meet the geometry of the building. Next slide. 2 minutes. Okay. I'll just breeze through the next slides. This is just a framing plan that Structurelam did of the sanctuary. It shows all the glulam trusses and how they are spaced out in the sanctuary building, along with typical connection details. Next slide, please. This is just a shop drawing showing what those glulams look like. Pretty simple shop drawings for the architect to review. was mostly just confirming lengths and radii. Next slide. So the one challenge we did have with the structural land was that they are located in Vancouver and we were in Connecticut. So we looked at glulam manufacturers in Canada, on the east side of Canada. There weren't too many at the time. I know now there's more that you can purchase from. But at the time, Structural Land was the one who had the best bid for the project, was the most willing to work with Sana on realizing their design. They were really excited about it. But of course, getting the beams from Vancouver to Connecticut required the trucks, which were carrying these 100-foot beams, to go almost to Mexico to get around the Rocky Mountains and then back up across the United States, because the trucks could not make the turns through the mountains. So it made for an extra long trip for the truck drivers, and there were maybe 20 loads like that were done that way. Next slide. This is just a picture of the glulams being offloaded in Connecticut on site, and they're offloaded by a crane. So you need a crane when you work with large glulam beams. It's almost like steel. Next slide, please. Just another photo of the glulam beams being installed on top of the ring beam. As you can see, they're wrapped in plastic. And this is really important. We had a lot of discussions early on about what to do with this. These would be out in the open for almost more than a year before the building was enclosed, watertight. So we had to keep the beams wrapped, and we put moisture monitors inside the plastic, so we can monitor the moisture inside. If there was rainwater in, we'd cut holes and inspect, take it off, clean it, and then wrap it again. Next slide. This is just a progress shot of the sanctuary. Here you can see the glulam beams, again, protected with white plastic, spray foam insulation in between them. The trusses have been installed at this point. The king posts and the cables, they've been tightened. And then underneath is the metal deck floor. Next slide. So this is a picture of the commons, which is the eating and dining space. You can see that we use the glulams, but then in between we use the 2x8s, which was the scheme we settled on. So 2x8s every 4 feet on center, and then the sheathing went on top of that. Next slide. This is just the underside of the progress shot of the canopy. So the 2x8s have been installed in between the LVLs and the glulams. And then this is furring strips that were used for the Doug fir ceiling that was put up afterwards. Next slide. And Meta, if you just want to go through these slides to the lessons learned, because there's just some finish photos of the space. Once it was done, you can see the glulams only express about 10 inches of the 22 at the bottom. The rest were hidden, where we had the mechanical and the conduits running for the lighting. And then just quickly on the lessons learned, I'm sure we'll talk about this in the discussion. You know, the great thing about glulams, it's both structural and architectural. So you don't have to add something to it after to make it look, you know, aesthetically pleasing. Again, get started early on in your process with a supplier and pre-construction. Start qualifying them and make sure they're part of the design process. Coordinate closely with your MEP teams. It's not easy to penetrate glulam beams. It's not like steel where you can cut a hole and then reinforce it. You can't do that with glulam beams. So you have to be very thoughtful about where your conduit runs and plumbing and sprinkler lines run. Make sure it's protected. And then also understand that glulam is a natural material. There was a lot of hand-wringing about, you know, the knots and the cracks and the, you know, the different nature of each piece of wood in the glulam. Why is that one dark? Why is that one light? And it's wood, it's a natural material. But what you can do is make sure you develop a robust protection program and a cleaning and repair program for afterwards, if it is going to be exposed. Last slide, I think, Meta. Right, so I'll just quickly mention that after we finished Grace Farms, we started a working group at Grace Farms called the Design for Freedom. And Sharon Prince and Bill Menking, who was the editor-in-chief of the Architects newspaper, started this group as a way to combat slavery in the construction material supply chain, which is unbelievably rampant. And I'm only bringing it up today for you to understand and look into, but gluams and wood are mostly from North America if you're building in North America, versus steel, bricks, and concrete could come from anywhere around the world. And the labor practices in a lot of those countries are very questionable. They use child labor and indentured servitude labor to make these products, and they're being used in our buildings today that we build in New York City. People don't talk about it, but it's there. And I just want to say that one of the benefits of gluams and wood is that it's from Canada or United States, which has very strict laws and rules about slavery in the workforce. So I think I'll leave it there, Meta. I'm sorry I ran over the time. Thank you.
Great. Thank you so much, Jay. This was incredible. I hope everyone put their questions into the chat. We will start, the moderated discussion and Q&A, and we will actually mix up questions from the audience with other questions that Fatu, my co-moderator, and I have prepared. So please, all panelists, can you please unmute yourselves? Fatu?
There you go.
Yeah, sure.
So, Fatu, can you kick us off with the first question?
Certainly, sure. By the way, thank you so much to all the speakers. This was incredible information and content that you've shared. I just pulled one question from the chat. I'll start with that. I think this was directed to David. Well, this is from David Benjamin and directed to Bill Kaplan when he was speaking. Question was, are there differences in ppm values across the globe in isoclines?
Well, yes, I mean, there are differences throughout the globe and also from day to day and season to season. But the numbers that we're talking about are, average global numbers at sea level. And so regardless of what the local variation may be, we all know that weather moves around the world with the temperature. And so the picture doesn't change in that fact.
All right, thank you so much for that, Bill. Here's another question, and this is for David Burney. And Ina Kovacheva asked a question about if the white paper that you mentioned during your presentation, if we can share a link to that white paper that Pratt did.
Yes, I did. I put a link in the chat, but I can put it in again if people didn't. If people have arrived after I put it in, they may not see it. So I'll repost the link.
All right, thank you. I'll ask one more question and then I'll pass it over to you, Meta.
Sure.
So how can the important effort to lower embodied carbon emissions be integrated and aligned with Local Law 97? Should the law be amended, or should embodied carbon be regulated through building codes or other incentives? I'll just open this up to the whole panel.
I mean, first of all, in order to deal with embodied carbon, you need to benchmark it, which is certainly going to be a 4 or 5 year project to determine, what is an acceptable level, well, even a normal level around the country. And so that's the first thing that needs to be done. And there are a handful of states, I think 5, 7, or maybe even 8 at this point, that are starting to do that, or cities and states, as well as Vancouver, and are already in that process. There's a lot of information available on this at the Climate Leadership Forum, which is available online. They sort of specialize in this. So I mean, clearly, when we get down to New York City, I mean, we really need to start moving towards that process of at least starting to study our own inventory of buildings and determine, what is an appropriate level to maybe cap it at, as you're doing now with the operating emissions in new buildings.
Do other panelists have some comments about that? Because this is super provocative and timely.
I think we're gonna need all of these items. I think we need education because I think still a lot of people don't know what impact embodied carbon has on our environment, because it's not really visible, right? The building is there, but you don't know the story. How was it produced? Where the materials come from? Also incentives, I think we will need them, because I think those buildings might be a little bit more expensive than the standard building. So I think developers most likely would not understand if it would help to get buildings built better, I think. And the policy changes, of course, we need the codes to change, because without code, we cannot really build the way we want to build. And unfortunately, I think this is an item that's really lagging behind and will delay us substantially getting things done. Okay.
I'd like to ask, Paul, if we're going to have a supply chain problem with actually providing all of those bio-based materials that may be needed or wished for, in the coming years, both for retrofits and new buildings. How do you see, you mentioned that, the New York State and Northeast forests are in fact suitable for, bio-based low embodied carbon products. But how do you see the overall picture for, how architects, specifiers, owners, developers can actually know whether these products are available?
Sure, Meta. So, I think what we've seen is that kind of manufacturing capacity in Europe is starting to mature. But manufacturing capacity in the United States, 3.5 years ago, there were just 2 mass timber or CLT production plants in the US. Today we have, or North America, excuse me. Today we have 9, right? So, and we continue to have an issue with mountain pine beetle throughout the Western United States, which is an invasive that's essentially decimated large forests there. And so there is interest in figuring out, essentially, even in the West, how we can increase capacity in a sustainable manner. And so there is room in the West for production capacity to increase. But even I saw your question beforehand, Meta, and so I just did a quick calculation. New York State softwoods would support approximately 70 million square feet a year of mass timber construction. So just in state, we have a capacity to reach out potentially on a sustainable basis to produce about 70 million square feet of construction. So I think, Meta, the current supply chain is tight. There's long lead times. The manufacturer's been a lot of interest, but the other part of the manufacturing process that I'll just shout out is, these buildings are successful because of the way they're delivered with a high degree of customization before they arrive on site. And so there also is a significant amount of need for manufacturing capacity of just the commodity CLT panels into the finished product that will be delivered. And so that's part of the supply chain that also is really lacking at the moment, and we need to build on that.
What about insulation products, bio-based insulation products? Are we going to see a whole new set of products available to us?
Yeah, so I mentioned the wood fiber product, which essentially can fit in well with the existing supply chain. So we have, most mills produce about 25 to 30% of the wood fiber, the biomass that enters the mill, is eventually used for something other than solid wood product. So it's used to help dry the lumber, et cetera, et cetera. That's a great supply stream currently that is available for wood fiber product insulation. As far as foam insulations, there's a lot of interest in storing forest carbon in a polyurethane-based foam. So instead of using a and so that's this is all critical in terms of time, but that's really in the research stages still. So I think what we're going to see first are wood panel products and fibrous insulations, and those will be on the market in the U.S. pretty much within a year, and we won't have to import it any longer.
That's fantastic. I hope you get a lot of funding to develop all of this.
Can I ask
So
a
there was
question?
Fatu.
Sure.
Paul, I have a question. So when these bio-based insulation products are developed, is there any, New York City is a big city and has stringent codes. Is there any outreach to the building department already now, how these products can be implemented and be used? I think that would be an important step to do already now. So once the products are available, actually we architects know how we can apply them legally.
Yeah, so I think, the key steps are having the ICC IES report for the product, right? So having it recognized. And so really that's sort of the rollout of late 23 is when they believe that it will be available. At that point, Werner, yeah, we will be pretty much trying to fire on all cylinders to help make people aware of the product as it gets introduced into the market. Hopefully the long-term goal is that it's not just, the 475s and those unique sort of boutique locations for purchasing these products, that they can really move into the mainstream. And so to make that happen, I think there's a lot of awareness that needs to be built. And I'm not sure, other than, private company marketing, I'm not sure that there's been a coordinated work sort of at a municipal level to try to, a municipal level to try to make sure the awareness is built. So I think we're lacking.
I think, yeah, it would be important, especially local law 97 coming into place, where all these facades have to be upgraded to have a bio-based product that actually could be used by co-op.
I'd like to address this on a broader scale. There's a serious lack of tools and information to enable any architect other than perhaps a large firm to make a choice between one particular material that's available and another. And I know that everybody's touting the EPDs, the Environmental Product Declarations, as a solution, but I don't know if you've ever spent any time looking at them. They're almost impossible to get through and make comparisons. They typically run like 12 to 15 pages of a lot of information, most of which is totally unnecessary to make a simple comparison between what are the carbon emissions of one particular product to another. And I mean, and whether you're looking at construction materials or carpet tile, these are all the significant decisions in detailing every building. And until we have a means that any architect can look at this and get that simple piece of information to compare it and make a choice, we're really not going to be able to go anywhere, because a lot of these benchmark studies are done on buildings that are already completed, but that's already too late. So architects need to be able to, when they're designing the building in the first place, to make these choices. And so I think we seriously need to develop that. And I think one thing which is missing, and I detail a lot of this in my book, is we really could use a carbon footprint labeling system. We have it for for products or fire protection, and we have it for insulation, and we have it for a grading system for restaurants in New York City. But we have no idea for one material to another, or even product for another, what maybe we should have a system of grading it from 0 to 5 maybe zero being things like, wood, which actually are sequestering carbon, or maybe highly recycled materials, maybe 90% or more, and 5 being something like cement, with grades in between, so that architects can easily see in construction products, pick on a scale of, without having to go through engineering calculations to make some of these decisions.
We have a two-part question for Jay. It says, regarding the last presented project in Connecticut, the continuous glass walls appear to provide no insulation. Was it not heated or cooled? That's the first part. And then the second part goes, also transporting the structure from Vancouver via the Southwest, then to Connecticut added substantial carbon emissions to the chosen system. What is the assessed energy use for this project?
So regarding the first question, the glass walls were insulated. They were insulated glass walls that took a long time for us to test at multiple universities in Europe to get a warranty on, but we did end up getting there, and they are insulated, warranted glass walls. The second question about the transport from Vancouver, yes, I understand that is a long trip to make, and a lot of carbon was emitted in that process of transporting those large Gluam beams. But no, I don't, Vidaris, I believe, was our lead energy consultant. So I'd have to check with them if there was an energy study done after the building was done. But I would say that, we didn't use steel, which is also, a carbon releasing manufacturing process. And we used glulams. And at the time, the only place we could get glulams that size, and I don't know if that's still the case, was in Vancouver, because of the size of the trees. Maybe that's changed since. I've heard there's new plants in Canada that you can get them from that large, but in 2012, when we started ordering them, that was the only place we were able to find.
Thank you. We also have a question. Can I present this last one? I'm sorry, Meta, were you going to say something?
Go ahead.
Okay. Can someone speak more about challenges posed by city regulations, zoning, building code vis-a-vis use of mass timber in New York? First part question. And the second, it says, the fact that the conventional construction industry is practically controlled by steel and other carbon intensive material manufacturers, developers, and contractors. I guess that relates to expanding on the first part of the question. So I'll just pose that to anybody on the panel. I can repeat the question too if needed.
I mean, I can't speak much about the code. I'll let an architect answer that question. But in regards to the building industry and the construction industry in New York City, there's just not any experience really with it. Not too much anyway. New York City is still maybe a 50% union in construction world, and materials are very split up by who does what. And if someone touches the wrong material, it gets to be a pretty nasty business. So Gluam beams, I think, are the things that there's an interesting question I think that unions need to figure out there. If we're going to start building larger buildings or institutional cultural buildings with Gluam beams, that who would do that work? Is that iron worker work? And like I said before, it is almost like steel work. It involves crane, it involves rigging, it involves derricking. But also it's wood, so the carpenters might claim it, but they don't have experience in New York City erecting large things with cranes and putting them up in the sky. So I think that's something that's going to be a challenge that we're going to need to figure out over the next few years in terms of how the building industry specifically responds to the use of Gluam and CLT. But again, the code, I really would have to defer to an architect to speak about that.
I mean, Meta, you can probably speak to that too. I know the New York City's been on the verge of adopting the 2021 International Building Code for a time, and that will permit mass timber construction to much higher elevations than we're currently permitted. And I think, do you know where they are with that, Meta, if they're about to do that?
Well, in November, the new, regulations will come into effect, as Werner mentioned. And they will allow 5-story buildings up to 85 feet.
85. How many stories?
5.
I think actually it's 7.
7? Oh, I'm so sorry.
5 to
So
7.
how do we get to 18? That's the question.
Exactly.
Well, we need to adopt the 2021 IBC that other
Exactly.
country have adopted, and this is actually what one of, what our Pratt report, our white paper recommended.
Yeah.
Werner?
Yes.
Call your council person. Yeah.
Yes. So I would like to field a student question. This is Jeff Graziano, who has another question for Werner. So he's asking, Werner, after you completed, the frame the frame project in Brooklyn, have you seen more interest from US and New York City clients to use mass timber?
Yes, we actually, our office did get a lot of questions about what our experience was and what we would recommend. So I think there's a lot of interest, and that it's great to see that people want to use wood, and I think wood is just an amazing material because it's the closest building material that it's related to nature. And we humans, even though we forget sometimes, we are part of nature. And I think we feel comfortable around nature, and therefore also we feel comfortable around wood. And especially, for example, if you can leave the structure like wood ceilings, CLT ceilings exposed, those finishes you feel comfortable around. Besides the embodied carbon, but I think it's also part of it because it's very close from nature.
As a point of interest, I don't know if it's still holding the record, but Norway boasts up until certainly a year ago, I think, the tallest timber building, which is 18 stories, mixed use. It houses a hotel, a restaurant, offices, apartments, and a public bath. It's 280 feet tall, and it's purportedly entirely built from wood for glue laminated timber columns, beams, and truss structures, and cross-laminated timber walls that bear secondary loads, including elevator shafts and stairwells. So perhaps that's something to aspire to.
Yes, that's my wish, that New York City would take a step to investigate. And is it really dangerous to build with exterior CLT walls that we have to prohibit it? Can there be more work done to actually make that step forward, to allow more wood? It would be good.
Yeah, there's been a step in Milwaukee is racing to actually top out a mass timber building that'll be slightly taller than the project that Bill just mentioned. So it's called the Ascent, if you're interested in looking at it. And it's also 18 stories, but it's a few feet taller. So North America will be on the map as the leader shortly with that project. I believe it's going to close out within a year.
Great.
So Paul, I think you answered this question in the chat, but I'm just going to run it again so everybody can benefit from your response. It was asked by Tanuja, how is the aspect of fire, loss of forest cover and strength compared to concrete and steel taken care of in case of timber high rise?
Sure. So I'll try to break those apart into individual issues. So the mass, if you will, in mass timber is essentially allowing us to look at timber as a material that has a sufficient capacity to have good resistance to ignition and excellent performance under a long duration fire and the ability to self-extinguish. So this was proved by a number of tests that were done at the Alcohol and Tobacco Firearms Facility in Virginia, where they ran repeated tests on simulated apartments built with exposed mass timber. And they were able to show that essentially after all of the interior furnishings burned out, the mass timber self-extinguished. So even when the sprinklers failed, the mass timber was able to self-extinguish. So in brief, essentially mass timber has to meet the same number of hours of resistance requirements of any other structural system as far as fire goes. As far as forestry goes, I think, I hope the point was clear that really we need to think about engaging and being engaged with the forest as an ecosystem and respecting what's going on there and harvesting in that manner. And to date, the best way to do that is to look to the guidelines that are provided by the Forestry Stewardship Council, or FSC. And they have developed a system to certify forests. They're being managed sustainably and also harvested sustainably. And so that's a way to ensure that we avoid ecological damage in the process. And as far as, the tall buildings, essentially, once we get up beyond 4 or 5 stories, typically the lateral systems are actually hybrid. They're using reinforced concrete or steel as the lateral system, but the gravity systems and the rest of the enclosure is still mass timber.
I'd like to hear from Gabrielle what she thinks about, this very big push toward bio-based and low carbon materials in the retrofit industry. How that is, what are the challenges? What are the opportunities? What needs to happen to really make a breakthrough there?
Well, as Werner mentioned, to my knowledge, I don't think the wood fiber insulation is able to be used on exterior walls right now. But foam insulation is equally combustible, and there's been some movement in the with DOB, particularly after tragedies like the Grenfell Tower fire, to kind of really think seriously about what the implications are of Local Law 97 and combustible building envelopes. So it would certainly be my hope that we're not looking at a future where we're just cladding all of our buildings in New York in foam panels. That is kind of where the research that's been sponsored by NYSERDA has sort of gone thus far in terms of looking at these prefabricated envelope systems. Yeah, Caleb is adding some notes about some of the policy stuff that is currently going on in the building department with regard to foam. So I think, having systems that are bio-based, or at least not as potentially environmentally damaging as foam, for retrofits are super important. Right now, the kind of main material that's ticking that box is mineral wool. But I think it's not inconceivable that as some of these bio-based insulation products come online, they can be tested and accepted as part of assemblies. But that's going to take a lot of work on the part of the manufacturers, paying for those tests and also marketing that and educating architects about how the materials can be used. So I think we're unfortunately a little far out from that, but I think the thinking is definitely there, that like what future are we really proposing? Like what future is Local Law 97 really proposing for our city, which is, honestly, we live in a very brick mass masonry city. If you look around, the material of New York City and a lot of kind of cities of similar vintage, we got a lot of brick. So, what is this going to look like? And that has implications beyond carbon. It relates to how people see and feel in their neighborhoods, right? Like there's a kind of cultural aspect to the materials that a city is built with. And so, hopefully we're not just talking about sandwiching, foam or metal panel on the outside of all these buildings as a way to save energy, because we might lose a lot of other, somewhat intangible qualities of the built environment if we did that.
I'd like to follow up with a question to our co-moderator, Fatu, who actually works with a lot of building owners right now as part of her role, as one of her roles in the New York City Accelerator. So where do you see the greatest opportunity for, transformation? What kinds of materials or systems you see could really be transformed at scale. Where do you see the opportunity, Fatou?
Thanks for that question, Neda. You know, when it comes to retrofits, the building envelope is an area that we have tremendous opportunity because we're not maximizing as much as we should. I think one of our presenters talked about the importance of that. I think it might have been Gabrielle, about how we're focusing on electrification, heat pumps, looking at the internal loads, where a great opportunity is looking at the building envelope itself. As we work with clients on a day-to-day basis of multiple different typologies of buildings, the envelope is the least opportunity that literally comes to the table from a retrofit perspective. But I think since we're talking about bio-based products, I'm going to ask Paul, like there are products that might hit the market in 2023. And I'm curious, between those products, and we're talking about insulation and how combustible it is, do you think some of those products may actually address some of the insulation, less efficient insulation that we currently have in the market? And what role can policy, from an AIA perspective, working with the Department of Buildings, look at these products that are about to hit the market and integrate it into the code requirements going forward? Because I mean, sometimes for us as consultants in the industry, it's hard to make these recommendations when there are no products in the market. And when we have clients who already have existing relationship with architects, the architects for these buildings are not necessarily looking at these innovative solutions, but when we know that it's available as consultants, we do propose it to the owners and also bring architects to the conversation and try to kind of have the right decision makers at the table looking at these solutions rather than using the business as usual products that are much more readily available today. Can you expand on that, Paul?
Sure, Fatou, thank you. So specifically, the fire testing of this wood fiber insulation, right, has not been completed for the IES certification yet, but the performance of similar insulations in Europe is that they're essentially Class B. So in terms of, our understanding, potentially that'll help designers wrap their heads around the opportunity that's presented. As far as, helping people to, if you will, consider an alternate route for business as usual, the wood fiber product is designed as a panel product that would really drop in place of other fibrous insulation. So if we think of mineral wool, for instance, this is very similar in terms of the opportunity. It's R per inch is similar. It's probably something like 3.7, 3.8 per inch. So it's a similar R value per inch as the other fibrous insulations. The profiles of the insulation, the thicknesses of the insulation, it can come with square edged, it can come with tongue and groove. So it can be used in very similar applications. And it is designed to be left exposed for a period of time. So the water will essentially, the way that the fibrous insulation is created is that the wood fibers, which are water loving and would absorb water, are coated with a wax surface, and the wax surface allows it to be to have water resistance that it wouldn't otherwise. So it is designed, in fact, to be left exposed. So the idea is to get these Fatou as close to the performance of existing products so that they can essentially be offered as drop-in replacements and not try to convince people that the total process is a different process than what they're used to.
But if I could just add to that, I think the issue is not necessarily the performance of the product, because we do have this track record from Europe where these have been used for a while, but it's both getting the testing done, as you mentioned, Paul, to the US standards, getting that accepted by the building department, but also having the kind of marketing to architects with details that are coming from a manufacturer as part of a system saying, hey, we've engineered this, you can use this detail. Because honestly, like that's, if we look at mineral wool and the amount of marketing that a company like Rockwool is doing and outreach to the AC industry with those, design guides, that's a lot of what is driving architects' choices to use a particular product or system.
I think we can exclude, other things we can exclude.
Yeah, so the, it is a nascent industry, this first company that's opening up in Maine, and I'll drop the link into the chat. So I'm not sure exactly, but my understanding is they're trying to get into really the building material supply chain, first and foremost, into some of the larger stores for building material supply. And so I'm sure, as you point out, Gabriel, in step with that, they've got to coordinate their activities, right? So the designers understand exactly what this product is. Yeah, I think that's the very bleeding edge of where we're at currently, right? As this comes online, will there be an awareness for the adoption of this as well as availability? And both of those have to sort of roll out in sequence and lockstep. So I'm not promoting the product, but I will drop the link into the chat so that you can take a look for yourselves at essentially what will be coming down the pike.
So do you expect more factories to open up? I mean, it's great to have one place in Maine, and is it correct they do bio-based insulation as well as mass timber products?
So they're focusing strictly on bio-based insulation, and it will be co-located at locations where there are current wood product fabrication facilities. So they are really using a waste product from that stream as the feedstock for their process. So to answer the first part of your question, absolutely. One of the recognitions with insulation, in particular this insulation, is that there is a big transportation penalty, right? There's a very low density material, and those are the materials that really economically suffer from long transportation distances. So there's actually they've got a business plan laid out for numerous facilities to be built based on locations where they feel they can sort of optimize their transportation to large markets and simultaneously have access to their feedstock.
So what about new mass timber manufacturer suppliers, prefabrication plants in the Northeast? Do you see something on the horizon?
So that's a sticky problem. We do not. So currently mass timber, you'll hear it pitched as this is a highly customized product, which it absolutely is. However, at the economic level, it competes as a commodity initially. And so currently, I mentioned those two large projects, the one Ascent in Milwaukee, there's another large timber project in Cleveland called Intro. Both of those projects are actually using European sourced mass timber. And that was an economic decision in both of those cases. And so that is because there's large monocultures which are industrially harvested and not necessarily with any sustainability criteria. In some cases, yes, but not necessarily. And so that allows them to have economies of scale that outcompete what we would be able to offer with our more mixed forest makeup that we have here throughout the Northeast. There have been 3 announcements in Maine that the timber facility will open up there. And unfortunately, in all 3 cases, they weren't able to secure their final financing. So there's definitely the interest there, but we haven't turned the corner here in the Northeast.
All right, I have a question from, hold on, let me see, Ayodeji. How do you ensure mass timber works in hot, humid zones with propensity for mold growth? Are there emerging standardization methods architects can rely on for these materials? It's open to everyone.
I'll just throw in that ASHRAE has written, ASHRAE 160 is a durability standard for the performance of envelope materials, including bio-based materials. And so they've given a very clear protocol as far as what it means to be durable for a bio-based material under hydrothermal cycling. And so we've been using that as the basis for all of the work that we do in terms of making sure that this product meets the building science criteria we want it to.
I mean, like any other building, mold growth happens through wrong humidity management, and usually it happens in the exterior wall. So certain climates require vapor retarders on the inside or on the outside or both. So proper mitigation of humidity should also avoid mold growth in wood or any other material like sheet rock.
Sure. I think when we're talking about bio-based products for insulation, in Gabrielle's presentation, I also talked about how the insulation can be applied inside, outside. So the building science component of it still stays in terms of best practices when it comes to addressing mold growth.
Yeah, I mean, I think you would just need to include some kind of control layer, air control for sure, and possibly vapor control or vapor variable control somewhere in your exterior wall sandwich, depending on the climate.
Yeah. All right. Meta, do you want to ask other questions that are in the list?
Well, I just want to field, we are a very, very, idealistic bunch, gathering on Earth Day to talk about decarbonization. And I love this group, and our audience is learning, and I am learning so much today. But I think the very big picture is, where we would like to move carbon emitting cities to cities as carbon sinks. So that is, a philosophical idea that actually has to sort of break through a cultural barrier. So I just wanted to, and that cultural barrier is not only with professionals like us, and people that really are already committed, but it's, how do we, make this more palatable and sexy and interesting as an idea to groups like owners that may not have so much familiarity with the data, the numbers that were presented today, and may not know all the benefits of decarbonization and lowering embodied carbon. So let's just hear from all of our panelists what really needs to be done for this to become a larger movement.
Education.
I agree, education.
But we're trying hard at Pratt, as you've heard from President Brone, but I think Pratt is sort of, already checked off here. So we're doing our part, but who else needs to be educated?
Well, I think, there are 95,000 members of the AIA. And of course, that's only part of the number of architects in this country. I don't know if it's 120,000 or more. And so, you get down to the local chapters, and I think that's where it really can happen very quickly if we can give them the tools. And that's really what's missing. When, I'm a member of the Bronx chapter.
Right.
And when I started to bring this subject up a couple of years ago, then everybody looked at me and said, okay, what do we do? And then, I don't know what to tell you. So, I mean, to me, this next 5 years is absolutely critical for us to get things rolling here. And we need to deal with giving tools to architects to be able to make simple choices, which can be put in buildings, in building designs and infrastructure designs immediately. That's my last thought.
So Jay, I'd love to hear your perspective. You're in the construction industry, you have an architecture background, so you have the best of both. So what is your view on the construction industry other than designers and engineers and their potential, receptiveness, eagerness to adopt, knowledge level, and this also includes unions and, all of the sort of labor sectors. So I'm just curious what your perspective is.
Yeah.
What needs to be done here to move this a little bit faster? Because I think that's Bill's main point today, was that we need to move fast. We have 5 years. That was the big slide, right? So
I think it's a combination of like both education, but also regulations to some extent. Like when I first started at CIAMI, my first project was the Bronx Library Center. And the Bronx Library Center, I believe, was one of the first LEED publicly funded buildings in New York City. It was in 2005, 2006, right? And at that time, when we were doing that, there was a lot of discussion about how much more LEED would cost, right? It was going to cost 2 to 3% more of the construction costs if we had to do this with the indoor air quality or the air handlers being efficient or insulation, right? All this stuff was like, at the time, seemed like an added expense. But in the past 15, 20 years, I mean, that's just become now what we do. And it's no added cost. We don't even blink an eye at it when someone says, oh, we want our building to be LEED gold or LEED platinum. Like, it's just part of what we do now. It's become part of our workflow. And I don't think the construction industry drove that. That was just owners and also requirements by different government agencies in New York, the DDC, the EDC, right? Parks requiring these things. And I think that's part of it, but also the education is a big component too, so that people understand what to specify and how to specify it and build it. We're at the end of the process, and we do what you draw. So what you specify, but cost wise, I think that it could be even faster than the way LEED worked into our normal workflow and our budgets as part of a project.
Great.
So
Well, I think, and I just make one comment about LEED. I think we need to pressure LEED to pick up mandatory embodied carbon. LEED is fantastic. It's done so much, but the fact of the matter is, you could be a LEED certified building and belch smoke, out of the chimney. So we need to get real with LEED or not rely on it as the standard, for, in quotes, sustainable design.
Right. And Bill, I wasn't saying that. I think that LEED is the solution. It's more about like the process and the way that it's sort of integrated into our everyday vocabulary as in the construction industry. That's my only point there. Right.
No, but all the more reason to get LEED to change a little bit to incorporate this.
Agreed.
I'll just jump in as the engineer in the crew. For the designers, one of the questions that I've had for a long time is if we're going to be using bio-based materials, particularly, for instance, on the inside of these facade panels, what should the exterior of these facade panels express? And I think Gabrielle touched on, right, there's such a rich history of the brick architecture of a city like New York. If we're talking about remaking the cityscape in areas where, large buildings are retrofitted with a surface covering, if that approach is taken, I'm curious to, what the next generation of architects would think that surface covering should be. And so certainly that's an area where I'd love to see some really creative thought applied.
Well, I think we're going to have another symposium about that and other things. So Fatu, do you want to ask the next question?
Yes. All right. So is NYSERDA funding research education for these products? It's a question is from Martha.
I'll just mention we do have some NYSERDA funding for the current research of developing the panels, but I don't know that they've put anything toward actually education or outreach about the products.
That it's directly on.
Well, there's quite a lot of work that NYSERDA is doing around retrofit, and particularly panelized, what they would call industrialized retrofit. But to my knowledge, there's not been a lot of specificity about the materials. So they haven't said we want to retrofit and we want to do it with, carbon neutral materials. They're more interested in just kind of getting retrofits off the ground as quickly as possible, regardless of the material of the panel.
Okay. I think we have one more question from, I don't recall who asked this question, but I'll go ahead and read it anyway. Here's another question for the board. Keel Mo has argued that R and U value standards in buildings are antiquated, as the thermal envelopes do not perform perfectly as designed. Also, he argues that because wood has different effusivity properties than steel and concrete, new R and U standards should be implemented for wood construction. is there a possibility of adjusting these RNU value codes for mass timber design? And is there a responsibility on users of buildings to adjust their lifestyle for more sustainable buildings? For example, buildings with more passive solar, heating and cooling elements do not have perfectly air-conditioned heated spaces. I think this is open to everybody. Werner, you wanna speak to that, because it's about code and we're talking about our values and your values being equated?
I honestly don't know about effusivity and how it affects the R value. So maybe an engineer can answer that. How wood is differently, why the R value is not correct compared to other materials.
Paul, is that correct?
Yeah.
I mean, I think that to my knowledge, effusivity is kind of talking about thermal mass and the rate at which heat is lost or gained by a material. And I would just say, if the primary way that we calculate heat loss through the envelope is based on conduction. That's what RNU values are representative of. And if we're doing multi-layered wall systems with high levels of insulation and heating, interior air to a particular temperature or cooling it to a particular temperature, that's kind of the way that our engineering and design standards are working right now. I know that Kielmo has done a lot of research on like radiant systems, et cetera, which, would work more by, conduction between building surfaces and people's bodies. So that would potentially work differently, but, I'm not sure that, it warrants a change to the entire way that we calculate heat loss through buildings. I would also just point out that mass timber is usually used as a structural material. So there's a bit of confusion sometimes between mass timber. Mass timber is a replacement for concrete and steel structural material. That's not necessarily going to say anything about what the building envelope is made out of. So it doesn't necessarily have a correlation between the U and R value unless you're talking about a wall system that's actually made out of like a CLT, which is not really typical for how we design wall systems. So there's just like a bit of confusion between what form the wood is taking and what role it's playing in the building structure.
I think we are coming up to almost the end of our symposium, and I would like to ask, our panelists and participants, including David Burney, if they would have maybe a hopeful sentence for our student body, what they can look forward to, what they should be working on, what is, for you in a sort of a one and a half sentence, a kind of a kickoff, exciting challenge, and how we can meet this, our decarbonization challenge and improve our cities. So go ahead, let's just go once around the room and then we wrap it all off.
Okay, well, maybe in 2 sentences. I think for our students, decarbonization is definitely the future. I think there are 2 takeaways from this discussion today. One is that our obstacles are partly the building code and partly the sort of inertia within the construction industry to adopt and embrace new technologies. So I think if we can clear the path by implementing the 2021 IBC, making these, perhaps even providing incentives for the use of mass timber and more carbon efficient things, the construction industry will follow, and people like Jay can help that happen.
Jay, let's hear from you.
Thank you, David. I appreciate that. Yeah, I would say as a former architecture student and turned a contractor, that to your students, spend time on the details and how the materials connect. And there's a lot of beauty that can be found in the way they work together. A lot of times, speaking as a student myself before, I spent a lot of time on the overall grand picture of things, and it wasn't until I started building that I realized that, the beauty in architecture is in the materials and how they touch one another. And I think you should spend some time in that this semester.
Great. Who wants to go next? Werner?
Sure. I recommend to explore the beauty of wood. Wood is just such an amazing material, and it has so much to offer. That's
Well, that's a very big topic in very few words. Thank you for that, Werner. Gabrielle, let's hear Gabrielle.
I would just say to think a lot about existing buildings, particularly for the architecture students out there. You spend pretty much your whole student career designing these amazing new buildings, like, an art museum, or, like the types of buildings that you might have a once in a lifetime chance to design and build in practice. So I would say look around you, because a lot of your practical work, once you get out in the real world, is going to be engaging with the built environment that we already have, and thinking about how to sensitively improve it.
Thank you. Bill?
Okay, so when I was at Pratt, after 34 years of an engineering career, I always got in trouble, especially in studio, because with an engineering background, I always questioned everything. I just wanted to know, why things were happening or what their value was. And that was not very well accepted. I was always getting into trouble. And so I would recommend to students today to do what I did, and that's continue to question when you have the opportunity to, as to the value of what we're doing in regard specifically to embodied carbon, in addition to the operating efficiencies that may be obtained.
Thank you. And let me give the final word to my wonderful co-moderator, Fatu.
Oh, thank you. Thank you, Meta. I just would echo what all of our panelists have said. I think architects have such a huge impact on addressing embodied carbon and operational carbon that, getting into the details. It's beautiful to look at the design, but the opportunities are in the details. And there are products that are hitting the market, not fully mature yet, but we need to get up to speed with them and be able to advise clients about these options. And that's how we're going to be able to phase out some of the existing products that we have that are problematic and doesn't help us address climate change as quickly as we need to. And, events like this are also very instrumental for students to attend, and they can learn a lot from it going forward. Thank you, Meta. I'll pass it back on to you.
Thank you, Fatu. And let me now thank all the participants and all the attendees for attending our symposium. I have a one last minute reminder for those who are seeking AIA or AICP credits. There are links in the chat that you need to click on. And I will leave the chat on for another 2 minutes so that you can actually find the adequate links and get your credits if you have attended the entire presentation. But other than that, I am just overwhelmed with the amount of information that we've heard today, and I hope that we will continue the conversation in future symposia. Thank you so much, everyone.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you. Have a good day.
Feel free to sign off. I'm just leaving it on for those who are seeking the credits. Okay. Is there anyone that needs to access the chat at this point? Okay. So I will end the meeting now, and I hope to see you very soon. Bye.
Bye, Meta. Thank you. Thank you for
you're
inviting
welcome.
me. Bye. Bye.